So again, I have to turn my computer to face me while recording because it's recording what I write, and then only about here is what's showing up on the screen. So that way I can make sure everything we do shows up on the video portion of it. So intersection of two sets. We have set A, set B, for example. The intersection would be the elements contained in set A and in set B. It has to be in both of them to be the intersection. All right. So symbolically, A intersects B. It looks like an upside down U. That's the intersection of it. It would be the elements that are in set A and in B. Okay, so that's what you would list. If it shows up in both sets, then you list it. All right. So the elements have to be in both for the intersection. So for the example, set A contains 1, 3, 5, 7, 9. Set B contains 2, 3, 5, and 7. The intersection which numbers are in A and in B? 3, 5, 7. So we would list 3, 5, and 7. And that's it. So what about under number 1, A and B? Find the intersection. The only letter that's in both of those sets is A. What about for B? Numbers in A that are also in B. There are not any. So it is the empty set. Again, you can do it. There's several symbols for empty set. In other words, the intersection of A and B does not exist. So we have an empty set here. So we're back to that word disjoint, meaning A and B do not share any common elements. They are a disjoint. So set A are the numbers 1, 3, 5, 7, and continuing on. So the odd natural numbers. Set B are the full set of natural numbers. So the intersection would be which ones? The odds. In other words, the intersection of A and B is set A. That works too. If the intersection is one of the sets, then you can just say it's that set as well. Okay. Questions on intersection. Again, we have to have overlap. They have to be in both of them. Union is our next piece. So the union of the two sets. These are the elements. In set A. They could be in set B or both of them. So in other words, every element of A and every element of B. So everything that's there is listed. Symbolically, the union of A and B. X is an element of A, or it can be an element of B. Does not matter. So the union here of A and B. Typically with numbers, you list them in order. So I have 1, 2, 3, 5, 7, and 9. To make sure I didn't forget a number, 1, 3, 5, 7, 9. So all of A is there. 2, 3, 5, 7. All of B is there. So that's everything. If there are duplicates, you don't list it more than once. Just like the letters that make the word happy, there's 2 P's in that word, but we only list the letters that make the word. So on number 2, find the union of each of those sets. All right, so the union of A and B is, we have our letters H, A, P, Y from the first one, and the additional letters of S and D. A is already listed, so we don't have to list it a second time. So for B, we have all single digit numbers from 0 to 9. So you can list all 10 of those out. You can use your ellipses to not have to list everything. If it's all the numbers, you write it, the first 3 to indicate the pattern, and then the last one to know where it is. Or you can write them all out, which is what I did on the first time when I did my notes here. All right, the union of A and B We have set A, which is our odd numbers starting at 1. Set B are the natural numbers. So what would be the union of the two sets? It would be your natural numbers. It would be set B. You could even use the natural number symbol, the N with the double line. Any of those 3 options is the union of that set. So the way I've listed out at first is the roster method, listing what's actually in the set. The others would be the names of the set. So when we're dealing with cardinality of these sets, cardinality of a union, we have to take in consideration that union, it could be in A, it could be in B, it could be in both of them. So we don't want to double count a number or something in the sets because it's in both. So the calculations are, we're going to add the number of elements in set A and the number of elements in set B. Okay. Then we're going to subtract the number of elements in the intersection. That way that intersection doesn't get counted twice. All right, so the calculation looks like this. The cardinality of the union. So cardinality is just the number of items, elements in the set. So how many items are in set A plus how many items are in set B minus the intersection. Because if we've added everything in A and added everything in B, that intersected area has been counted twice. So we have to take the overlap away. So when we do the math of this, we have the elements in A plus the elements in B minus the intersection. So 10 plus 20 minus the intersection. There are 26 distinct items in the union. We're not counting anything twice. So what would it be on 3A? So the union, cardinality, how many are in that particular set? So 23 in A plus 17 in B minus 7 in the overlapping area. So that would make 33. So what do you think about B? If A and B are disjoint sets, the cardinality of A is 37, the cardinality of B is 43. What, in other words, how many are in the union of the two sets? So we know 37 in A plus 43 in B minus the intersection. How many is in the intersection? Exactly, 0. There we go. If A and B are disjoint sets, there is no intersection. There are two completely different sets. Okay. So again, cardinality, I'm just asking for how many things are in the set, how many elements. So, understanding the words that we're using here. When we say and, are we talking about intersection or union? A and B. Yep. A or B. One or the other. That's our union. So if you're given words, then understanding what symbols we use with that. So A and B. So which elements, numbers in A are also in B? Which ones are they? There's one of them. What's the other one? A or B. So we're going to list everything out. So 0, 3, 4, 6, 8, 9, 12, and 16. So 0, 3, 6, 9, and 12, 0, 4, 8, 12, 16. So just checking the individual sets, making sure everything's there. A or C? So 0, 1, 2, 3, 5, 6, 8, 9, 12, 13. Unfortunately, it's not all the numbers in order where you can use a shortcut. So we have to list everything. That last one, 2 different things happening. The first thing, I have the intersection of B and C. From there, the union of that with A. So the intersection of B and C, 8. Eight is the only number in both B and C. Now that combined with A. So 0, 3, 6, 8, 9, and 12. So all the elements of A, then and 8. So see what you can do with number 4 with the letters that are in each set, A, B, and C. So A or B. When we're dealing with letters, easiest is just to list out the one set, and then A is already included. So we need W, E, S, O, and M. A and C. So we have the words for math, or we have the letters for happy. The only intersection, A and H, are the only 2 letters included in both sets. B or C? So A, W, E, S, O, M. The only 2 letters not included in that set that we need to add are T and H. A and M are already there. So the last one, the intersection of A and C, and then that intersection with B. So first of all, the intersection of A and C, we have, that's A and H. So of those two letters, the only one that's in both of them is A. So we have the intersection of A and C are the two letters. Then that intersected with B, A's in. That's it. That's all we have. All right. So, looking at the next statement, it's descriptive of what they're dealing with. So we have cake, we have ice cream. You can have to use C and I to label those so we know which one we're talking about, or you can use A and B. It's really different. So we know we have 54 people at the party. We know 30 people requested cake. We know 20 people asked for ice cream. And we know 12 had neither of those. So the question is, how many guests had cake or ice cream? 54 people total. 12 people had nothing. So we know 42 people had at least one of those things to eat. We know in that 42 people, some of them had both. The next question wants to know how many had both. So let's go back to the formula for that. The union of your set, how many people had cake, how many people had ice cream, minus the intersection. The intersection is what we're going to try and find. That's what we want. So we know the union is 42. 42 people had at least one of those things. 30 guests had ice cream. 30 guests had cake. 20 guests had ice cream. How many had both? So in that 30 and 20 is also the intersection, because we have to subtract that part that's counted twice. So 42 people had something to eat. So out of that 42, how many had both? that overlapping is really sweet. That was good. 8 people had both. So you're solving an equation to find that out. Okay. So using your information, using your formulas, plugging in the information you have, see what you have left to figure out. All right, so the first set of Venn diagrams we're going to use have the actual elements listed. So we have the single digit numbers from 0 to 9. Set A contains 1, 3, 5, and 7. Set B has the numbers 2, 4, 6, and 8. And 0 and 9 are not in either set. So the union of A and B would be the numbers 1 through 8. Because those are the 8 numbers that are in A or B. The intersection of A and B. Do A and B share any numbers? No. So it's an empty set. The intersection does not exist. It is an empty set. You can use that. You can use the empty set symbol, which is just a set with nothing in it. All right. Complements. So the complement of B would be any number that's not in set B. So that's going to be 0, 1, 3, 5, 7, and 9. So we have the 4 numbers of A plus the 2 that are just hanging out outside of both of them. So the complement of a set is anything that's not in it. How many numbers are in this complement? 6. So that's the cardinality of it. So again, that in front is just asking how many items are in it. Okay. All right, so what about number 6? We have 1 and 9 just in A. We have 2 that's in B. We have 3, 5, and 7 that are in both of them. And we have 0, 4, 6, and 8 not in anything. Okay, we'll finish up when we get back. All right, so A intersecting B are clear. We have 3, 5, and 7 that show up in both. For the union, would be 1, 2, 3, 5, 7, 9. All right. So the next two involve the complement of B. So my recommendation is somewhere write what the complement of B is. And that would be any number not in set B. So 0, 1, 4, 6, 8, and 9. Because in set B, we have 2, 3, 5, 7. All the rest of the numbers are not in B. So the intersection of A and this complement would just be 1 and 9. So how many elements are in that set? 2. So again, that in front is really just asking how many elements are in the set. There's 2 of them. Okay, so 7 and 8 involve the actual number of items in the set. Not what they are, but how many. Okay. So when we're looking at the next group, there are 5 numbers that are in both. There are 2 numbers that are just in B. There are 7 numbers that are just in A. And there's 8 that are in neither of those sets. So the number in A or B would be 7 plus the 5 that overlap plus the 2. So that would be 14. So when they list it like this in a Venn diagram, if we look back at the other one, the overlap is not also seen here in just A. Okay. So when they list it in a Venn diagram, they've already pulled duplicates. So A and B would just be the 5 in this overlapping area. Just in A would be the 7 and the 5. So there are 12 items that are in set A. Okay. So looking at 8, answer similar questions about number 8. So there are 23 in A, 17 in B, 10 that are not in either set. So A or B. Oops. So there's 40. A and B. There is no intersection between them. So those are disjoint sets.